I mean, I honestly did not expect so many people to show up tonight. So that's really an overwhelming experience. Thank you all for coming here tonight to the launch of the first Samfunnsgeografen in 5 years. So before we get to the launch itself, the reveal of how it will look like and everything, we have something very, very, very exciting for you. So you have probably noticed this crazy setup. This is going to be quite a unique experience. It's going to be a performance lecture by our own postdoctoral fellow, Steve Williams, aka Noise. So I don't think I can begin to explain what this is going to be. I think this will be just explain itself when it begins. So please give Steve Noise a round of applause.
For many years, we were told a story that we are separate from nature, that nature is separate from us, that nature is for us to control, to colonize, to dominate, to use. That we are separate from the more than human. But we are a part of nature. Nature is part of us. There is no separation. We are connected to the more than human. Ours are not the only voices that matter. They are not the only voices we can hear. There is no separation. It is not possible to draw a line between what counts as us and what does not count as us. We make sound together. We make our worlds together. We make our futures together. We dance together. And can ask, who is the we in this story? We can hear the voices of the air, of plants, of bodies, of light, of the waves of radiation that surround us, of the particles floating through the air we breathe. We can hear the earth breathing if we listen.
So, hello everyone. Thanks for coming. This is way more people than I expected to be here, so thank you for that. So as introduced, this is going to be a performance lecture, so I'm going to explain kind of what's here. And I was going to say you can come closer if you want, but I don't know if there's actually enough room to do that. So we'll have some time at the end for questions, and I'll be hanging out for a while. So if you want to talk about what's here or ask questions in more detail, you're more than welcome to. Sorry, I got to start my timer. So I'm Steve Williams. I'm a postdoc here working on sound and uncertainty and sustainability. Most of my research has been on hydroelectric dams, so going to sites of hydroelectric power in Norway. I'll be going to Nepal in April, doing underwater recordings, electromagnetic field recordings inside the turbine hulls, understanding how soundscapes are affected by hydropower development. But today we're going to talk about cyborgs. Actually, you know what? I forgot to introduce who I am. So my artist name is Drew's Noise, which my niece and nephew gave me when I was doing my PhD. They started calling me Dr. Uncle Steve. So DRUS, Dr. Uncle Steve, Noise is my artist name. So most of the time I play live techno, but I also do experimental sound art and yeah, a lot of sustainability kind of focused things. So this piece is based around Donna Haraway's concept of cyborgs. Is anyone familiar with Donna Haraway's writings? Okay, this is the right audience to ask that question. So cyborgs have been, the idea of cyborgs has been around for a long time in science fiction and merging man and machine and humans and machine. But Haraway was sort of looking at that as a way to deconstruct social relations and think about how are we actually creating hybrid beings, and that what does that do to how we think about our social relationships that we want to build. So the performance lecture today is going to be actually building cyborg instruments. We've got plants, we've got light sensors, heartbeat sensors, electromagnetic field microphones, and some other things that I can't remember, but I'll figure out during the performance. And I'm interested in sound for a couple of reasons. So this is a quote from a sound studies book talking about some of the things we can learn from sound. When we listen to things, when we pay attention to sounds, we can actually discover new worlds. When we listen to sounds underwater, you can hear not only sounds of fish, but water running. At sites of hydroelectric power, you can hear the sound of the spinning turbine that's being fed down through the river. You can hear the sounds of electromagnetic radiation, and we can try and listen into frequencies that humans can't hear, that birds and dolphins and dogs will actually hear and communicate in frequencies above what we can hear. Whales, elephants, moles, and fish will communicate at frequencies lower than we can hear. So we can actually bring that into our range of human perception. And I'm really interested in exploring that. This is another quote by Sanna Groth. She's a sound studies scholar at Lund University in Sweden. And this is her reformulating another piece by Haraway. So Haraway, in her original piece, was writing about vision and how vision is a dominant sense that we use. And she was using that as a mirror to the dominant ways we structure society, specifically maleness and patriarchy, and thinking about if the dominant sense is vision and the dominant way of managing and sort of organizing society is male, what might be other senses, other ways to explore society. So Sanna reformulated, if you look at the original piece from '88, you could replace hearing and sound with vision. So Sanna was reformulating this through sound, thinking about, we can ask these questions of who's listening, who decides that, who has the power to listen, what are the technologies and histories that are embedded in all these wires and cables here, whose voices are heard, whose voices are silenced. So it gives us a way to get into to this kind of intellectual ideas, but through sound. So that's what we're going to do today. Oh, sorry, I have a reminder that says, let it breathe. You may notice I'm talking kind of quickly. I've had about 25 cups of coffee today, so I'll try and sort of calm down a little bit. So what we're going to do is walk through a number of different ways of building cyborg instruments. And let me just see if I can flip over to the camera view. So yeah, so if you can't see on the table, you can at least get an idea of sort of some of the things that's going on. If you can't see clearly, feel free to come up afterwards and we can sort of walk through some of those kind of things. So the first thing we're going to do is actually think about how can we create sounds with plants. So this little synthesizer here is basically just making that sort of deep bass drone sound. But we can take some of these cables and we can take this one here and put it into the ground of the circuit. Is anyone here like engineering, electrical engineering, computer science, maker, builder kind of people? Okay, again, this is the right crowd for Donna Haraway, the wrong crowd for circuit building. Maybe in a different building. But then we can actually take these here, and if we clip this to the leaf of the plant, you should hear. So you can see that characteristic of the sound changing. Sorry, hold on one sec. It's not getting into the actual ground. And for people in my department, I stole these plants from our lounge, so they will come back. They won't be electrocuted. They will still be alive at the end. So the sound that we're hearing, that deep drone sound and that pulsing, is because we've actually now made the plant part of the circuit of the synthesizer. So we're not hearing the sound of the plant. We're not putting a microphone on the plant. We're actually connecting the plant itself into the circuit of the synth. So we've already created a little cyborg instrument, and that sound that's produced and those pulses and those rhythms are going to be affected by the water content in the plant, how thick the leaves are, the electroresistance, how fast it's kind of running through that. And if I play this, like with a touch sensor,
synthetic and organic, natural and unnatural, human and machine. What is the difference? Are we not already connected? Are the plant and the body and the machine not one and the same?
So I find this a really interesting approach for thinking about sound and our relationship with the environment. Just like that piece that was the beginning, for so long, I mean, it's not a new idea, especially for this crowd, that nature and humans are not separate things, they are intertwined. But for a lot of our history, we've been told that they are separate, that humans are over here and nature is over here. And the logical extension of that, if we want to protect nature at all costs, there shouldn't be any humans. It doesn't really make sense to think about those as separated pieces. So this is a way to kind of connect those together through building that cyborg instrument. But there's other ways we can do that as well. So we can take this one over here. And sorry, I didn't mean to be rude earlier, but I hope you can understand why I didn't want the beers on the table. Yeah. I've had that experience before. So now we've connected this little thing. You can see these lights flashing here. We fade that in.
Electric currents. Electric currents flow through wires and cables and transformers, through living beings, our skin, bodies, the leaves of the plants around us. The flow is always changing. Bodies are always changing. Plants are always changing. Electric currents flow. Electric currents. Electric.
So with this one, we're doing a very similar thing that we did before. We We've still got the wires connected to the plants. It's detecting the electroresistance. Down. No. I like playing loud. Okay. All right. Can everyone still hear me? Okay, cool. So here, we're actually connecting the plants and the wires into the circuit of the synthesizer. So we're changing the characteristics of the sound. But to make sort of something happen, I needed to touch it, or we needed to wait for the rhythms the plant would create. Here, we're measuring the electroresistance, but that's actually triggering those sounds in the synthesizer. So these kind of chords and pads that you're hearing, once again, we're not hearing the sound of the plant. The plant is playing the synthesizer. So depending on, again, the water content, these don't look like they've been watered for a while. So all of those kind of things will affect and create that unpredictability in the sounds. So that's kind of like, part one, thinking about how might we interact with plants. But another element of the more than human is thinking about all these things that surround us that we can't hear and we can't see. Things like radio waves, electromagnetic radiation, everything that's coming out of the phone, everything sort of from all these power supplies, the electrical transformers outside power stations. So we can also kind of play around with that a little bit. And this is actually something that worked really well in my office upstairs on the 3rd floor. Being buried in the basement is not the best radio signal. So we've got a bit of an antenna here, so we'll see if we can actually pick up any radio signals down here.
We swim in the waves of the world. We hear the sound waves. We see the waves of light. Radio waves flow through the air. Invisible. Inaudible. Until we tune in. We hear the world around us. We hear the static and the sounds in between. What we hear changes. We hear the world.
So we didn't hear some nice radio voices, but for people at the back that couldn't see, this little microphone here is an electromagnetic field microphone. So most of the time, if you have a radio or you have a phone, those microphones are actually designed to not hear all this kind of background static. But with this mic, we can put this against a power supply through here, around here, or some of the power supplies that are under the table. We can actually start to get a sense of all these waves that we're swimming in that we can't hear. And we can use those waves to make some other kind of sounds. So we go another plant connection.
The electronics. The electronics. The magnetic fields. The magnetic fields. The wires. The wires. The interference. The interference. The noise. We tune out the noise. We ignore and hide the ether. What happens when we tune in? When we listen to the anti-radio.
So here we're also playing with electricity, but here we're actually playing with the electromagnetic field. So these wires that go into this little machine here is actually measuring the electric field that all living beings create. Humans, fish, anything that's alive creates an electromagnetic field. But I can actually interact with this. So even when I'm not touching the plant, I'm interfering with its electromagnetic field, so it actually changes the pitch. If I actually grab these, so now we sort of created something that connects the physical plant that we can see, the human body, and the electromagnetic fields that are all around us that we can't actually see. And another piece of electromagnetic field is light, just at a higher spectrum. So let me bring in. So we've got another drone sound. Coming from here, and that's just the pitch. But this is a little LCD light sensitive panel. So there's no power connected to it at all. But when there's a light hitting it, it'll send out a high voltage. When it's covered up, it'll send out a low voltage. So if I take this cable here and plug it into the pitch, so now we can actually use light to control this. But interesting, just like that sound and this light and controlling that, this is not actually quantized to a pitch. Like unless I can really, really get that close, it's not the same as like the semitones you'd find on a piano kind of scale. And I find that another interesting way to kind of get into some of the things that both Haraway and Groth were talking about, because for many hundreds of years, unless music could be played in a concert hall in Vienna, it was not real music. So anything from Africa, from Southeast Asia, from Latin America that didn't use a 12 semitone scale, that was not music, just noise. And it's a very Western colonialist focus of what is music and what is noise. So I like sort of playing with the plants and with light and electromagnetic radiation that don't really respect any notions of colonization or Western dominant thought. It's just sound.
Light surrounds us. Light gives life. Light animates. Even in the darkness, there is light. Light surrounds us. Light gives life. Light animates. Even in the light, there is darkness.
So as much as all of those things, I'm going to unplug this. Sorry, I love the concept of that. I'm not a huge fan of that particular sound. I am in control, so I can turn off that sound. So as much as we have all these things swimming around us, all the things that we can't see, the plants and everything that surround us, we're also humans, and we have bodies that exist in this world. So we can also play around with that if I can figure out where this cable is. So right now we have this drone sound coming in. That's just one continuous sound. But if I put this on my finger here, I don't know if you can see that on the camera, you should be able to see a red light flashing there that's actually picking up my heartbeat. So instead of making this a drone, if we actually make that a trigger, and we take a copy of my heartbeat signal and plug it in here,
Hearts beat, rhythms and patterns of the body.
can you play with
The heart absorbs, responds,
hover it up and turn to the light?
listens
Then you can play the pitch of
to
my
sound.
heartbeat. Put your hand over the top of the
Heartbeats resonate with the sound
and then
around
shine your
us,
flashlight from your phone on it to
racing
make it a higher
fast,
pitch.
slowing down. In control and out of control. Always beating. Always changing. Always rhythm.
So we've got one more plant left. So we'll use this here. So now with this one, we're actually going to use that to change the character of the sound. So now we've actually created another sort of network in cyborg of this is my heartbeat. So once again, you're not hearing this, that's not the sound of my heart. The heartbeat is actually triggering that sound. Then you are playing my heartbeat with the light, sort of making that. So we've got light and another human interacting. And then we've got this plant here measuring the electrical resistance from that plant, which is modifying the sound. And here the sound is not constant anymore. The timbre and the sharpness and the darkness is actually changing. And I'm not controlling that, but the plant that's controlling that. So if we want to go a little bit farther, we could say, okay, let's take this heartbeat and let's make a clock out of it. So actually, how many people here are either DJs or make electronic music, like on their laptops or anything like that? Okay, once again, wrong crowd for that. But if you've ever, even if you've been to a club, you know there's like a beat per minute. Like house music is around 127, the techno I play is around 150, breakbeat is like 172, and usually that BPM, the beats per minute, is fixed. You type a number in a computer, and that's locked. Or you turn to like a knob on your synthesizer or your iPad, and that's exactly the beat. Heartbeats are not like that. Heartbeats are regular, but they're not exactly regular. And okay, let's see if I can actually do this. I can see if I can slow my heartbeat down. Okay, maybe if I hadn't had 25 cups of coffee, I would be able to do that. But in theory, you should be able to sort of move that heartbeat up and down. So let's see what it sounds like if we start to play a bass line with that clock. And then maybe actually, sorry, can I borrow your heartbeat? Can I borrow your heartbeat, please?
Yeah.
Okay, cool. So just put that one with the little yellow thing on the top of your finger, just like that. You have no heart. Okay, there you go. Okay, perfect. So we had this flower that was just making that big drone sound, but like, why don't we turn that into a kick drum? So if we take, and we can do the same thing with that electromagnetic radiation we had. And maybe we can take some more electromagnetic radiation, create like another rhythm percussion line. Could I ask you to put that on like some of the power supplies down at the bottom there? So you'll be changing the sound of that percussion. You can move it to different power supplies to get different sounds. I'm showing here, which you can't really see unless you're kind of up close, is setting up feedback loops. So feedback is one of the most common things in any kind of natural system. So this little bit here is a transducer. So basically this is inside any speaker, and usually when my voice is speaking, you're hearing these sounds. It gets translated to electricity, runs through these wires, through those wires, up the ceiling, and then that sort of vibrates the speaker back and forth, and you receive that as sound. Here, instead of using a speaker, we're actually putting it on this. So we're actually hearing, if you want to put your hand on that, you can feel that vibrating. And then this is a contact microphone that actually picks up the vibrations. So we can turn that up. And then we can send the output of that back in. So we actually set up a feedback loop. So instead of hearing feedback through the air, we're actually setting this up here. And no, you're not having a heart attack. I just turned up the multiplication of your beam.
We were told a story that we are separate from nature, that nature is separate from us, that nature is for us to control, to colonize, to dominate, to use. That we are separate from the more than human. But we are a part of nature. Nature is part of us. There is no separation. We are connected to the more than human. Ours are not the only voices that matter. They are not the only voices we can hear. There is no separation. It is not possible to draw a line between what counts as us and what does not count as us. We make sound together. We make our worlds together. We make our futures together. We dance together. Ask us to read this story. We can hear the voices of the air, of plants, of bodies, of light, of the waves of radiation that surround us, of the particles floating through the air we breathe. We can hear the earth breathing if we listen.
So there we go. Thank you. Thanks. Thank you. Thank you so much. Thank you so much. Thank you. Thank you for your heartbeat. Thank you for that. And thank you for the percussion too. Thank you all so much. That was amazing. This will be my last bit. So just if you want more information on Donna Harry's writing, Sonic Roth, or more on sound studies, the references there. I also wanted to highlight just a couple of the places where things came from, so that those explanations about heart and light and radio, that was text that I wrote, and my collaborator in Berlin, Erbse, they did the actual performance of that. The idea of building a set based on heartbeats and clocking a system and actually using that as a way to sort of show how anxious or nervous or calm you are. my friend Jeanette Petrick. She's an amazing, amazing sound artist based in Enschede in the Netherlands. So you can definitely check out her work. And I interviewed her on the radio show that I do on Sustain FM. And the idea of tactile feedback, of actually doing feedback loops through physical materials. Andreas Kuna, who was in Tromsø, I'm not sure if he's still there or not, but an incredible sound artist doing really interesting work. So with that, I'm happy to take any questions if anybody has questions now, or if you want to have a break and then come back, but I'll be around for a little while. But any immediate questions? Or, yeah, go ahead.
What's the difference between plants and fungi and other organic matter that lives?
Right. In terms of how it makes sound, you mean?
Yeah, because
right.
I watched a lot of mushroom concerts.
Right.
But not the plants so much.
So for people that couldn't hear the question was, what's the difference between different kinds of plants, like fungi or trees or houseplants? So most of the time when making sounds or music with plants, it all comes down to electrical conductivity. So it depends how fast the electricity will go along that particular medium. So mushrooms, or like if you put it on like the bark of a tree, that doesn't really conduct electricity, so you wouldn't really detect the sound. But mushrooms, when they actually have that kind of web and the filaments, the electricity will run along that. Because this technology here, like these pads, that was actually invented for physical therapy. So if I like hurt my shoulder muscle, the physiotherapist, they can put it on my arm, and they can measure how fast the electricity runs through my muscle and tell whether it's a healthy muscle or a damaged muscle. So it's the same kind of thing that you're using. The other approach is you can have really sensitive microphones. So you can actually hear, like you can take a version of like this contact microphone, and you can stick this in the ground beside a tree, and you can hear the sound of the water being sucked up through the tree. Or you can put a microphone like in a petri dish and hear the sound of mushrooms growing. The challenge I have with using that is that you kind of have to do that in a lab, because the microphones are so sensitive. If we had a little petri dish of mushrooms here, it would be completely overwhelmed by the sound of the kick drum coming through the speakers. So you can do some of those recordings and then bring it out. Yeah. So, yeah.
Thank you.
You're welcome. Any other questions? Go ahead. Yes. Yeah.
Can you play like one little more thing? Because I didn't.
Yeah.
I was a little late. Do you have like 3 more minutes? Can you play
I can just talk for a few more minutes.
No, can you just play one?
Oh, play one thing? Okay. Sorry, have a request for to play one more thing. I don't know exactly what I can play. Why is there no, okay, yeah, because there's no one's heartbeat's actually going. So we just need like a few more minutes. But I don't even know why there's no kick drum anymore. So yeah, maybe just one thing about the sound, because I talked about it a little bit. I just want to mention so yeah, this little thing here that's actually translating electricity into sound through speakers is called a transducer. And that's also what happens if like you've probably seen Instagram videos with like dolphin sounds or mushroom sounds or those kind of things, or like the sounds of bats. And those we can't actually hear, but we can record those, and we can slow that down and bring that into the human frequency range. So in some ways we're hearing the sound of the bat, but we're not exactly hearing that. We're hearing a transduced version of that. And I didn't really mention that during the performance, but that's another interesting thing I find about sound and connecting to politics, because that's what often happens when we're working with marginalized communities or doing field research, is that we're sort of taking someone's voice, translating what it is that they said, translating what the way they want the world to be, bringing that back, turning that into academic language and pushing it into a paper or into our thesis. Or in politics, we're speaking on behalf of some kind of class of people. And so sound actually, I think, gives an interesting way when what does it mean when we actually, it is valuable for translation. Like I don't speak Spanish, but reading Gabriel Garcia Marquez's novels in an English translation was wonderful. I don't speak ancient Greek, but reading Homer is really interesting. So there's nothing wrong with translation per se, as long as we're aware about what are we gaining and what are we losing when we're bringing in those different sounds and different voices. So anyway, I'll be hanging out here after the whatever happens next. Sorry, I lost track of the time. But thank you all again for coming. I've got stickers here for my artist name and also sustain.fm. I do a monthly radio show interviewing artists that are working on sound, music, and sustainability, and run workshops on field recording, microphones, working with climate data, turning that into sound, that kind of stuff. So feel free to grab some stickers and talk to me about anything you want. Cool. Thank you again.